This is the human brain, 3 pounds of flesh that form the central organ of the human nervous system. It receives sensory information, controls our physical movements, and it somehow creates our consciousness, thoughts, and lived experiences. Though scientists and philosophers are still trying to figure out how exactly that happens. Though we do know what different parts of the brain do. The largest parts are the cerebral hemispheres in gray, which have those deep folds of nerve cells and nerve fibers known as gray and white matter. The blue part at the bottom is the cerebellum, which controls balance, posture, and motor control. The yellow and red parts are the limbic system, which regulates our emotions and behaviors, and helps with social processing. And this here is the pineal gland, a small structure located at the back of the corpus callosum that secretes the hormone melatonin, which plays a role in regulating our sleep cycles. However, for the French philosopher René Descartes, the pineal gland had a much more important job than hormone production. According to him, it was the location of the human soul. Descartes proposed that the pineal gland was full of animal spirits, of a very lively and pure flame, that move out from the brain and into our muscles and nerves. In other words, Descartes argued that the human soul was part of our physical anatomy. Now, this may seem like a curious claim coming from a person known for helping to usher in the age of philosophical skepticism, but if you believe that the soul is flowing through your nervous system, then the pineal gland, located deep in the middle of the brain, was as good a guess as any for where the immaterial spiritual realm might intersect with our very material bodies. The pineal gland does not, in fact, contain a very lively and pure flame, to our knowledge. And scientists aren't really looking for supernatural phenomena within our bodies, but in recent years they have been looking for where human religiosity might be located in the brain, the God spot as some have called it. In 2021, following a study conducted by a Harvard neuroscience team, headlines focused on the periaqueductal gray, seen here in blue, which is located deep in our brainstem that connects the prefrontal cortex and the limbic system. The study found that damage to this circuit was directly related to people considering themselves to be less religious. So, have scientists found it? Is there a religious center of the brain? So the short answer is no, there is no God spot. The problem with the God spot, besides the fact that it's a terrible name that presumes religion equals monotheism, is that it also presumes that there is only one spot. If you dig beneath the headlines, you'll find that most neuroscientists of religion are not trying to find any particular spot. Even in that 2021 study on the periaqueductal gray, the researchers were very careful to note that this is a complex circuit that extends throughout the brain. Instead of looking for the religious center of the brain that can explain all of religion, neuroscientists are trying to understand the brain networks involved in some of the complex emotions, beliefs, actions, and experiences that we call religious or spiritual. Religion is complicated, so it's no surprise that the neuroscience of religion is a huge and diverse field studying different parts of the brain. Experiments can involve nuns in fMRI machines recalling spiritual experiences, Buddhist monks meditating while wearing EEG caps, and people completing word puzzles to simulate analytical thinking. And over the years, neuroscientists have found that when people do religion, there are many different relevant parts of the brain acting at the same time in dynamic, ongoing relationships. To get a sense of this complexity, check out this figure from the neuroscientist Jordan Grafman. Every spot here marks a region of the brain that researchers have connected to some sort of religious cognition. Religious cognition is a technical label for the psychological processes that we typically call religious or spiritual. So reciting a prayer, that's a religious cognition. Evaluating a theological claim, that's also a religious cognition. Feeling one with the divine, you got it, religious cognition. The scope here is pretty wide. There are a few things we can learn here. The first is that there's clearly no single God spot. Instead, we've got areas all over the brain involved with religious cognition. The second thing to notice here is that none of these regions are just for religiosity. The brain is amazingly flexible. The same networks that help us navigate social situations might also help us pray. To quote the experimental neuroscientist Patrick McNamara, brain imaging studies have shown that religious and spiritual experiences and practices such as prayer are associated with the upregulation and downregulation of neural activity in multiple regions in the brain. As an example, let's consider these purple spots, which represent the areas that support theory of mind cognitions. Theory of mind is a technical way to describe how we mentalize or think about other people's thoughts, feelings, and intentions. Some research on religious cognition has shown that the same regions involved in typical theory of mind tasks can be active when religious people pray or when they think about their God's intentions, emotions, or moral concerns. In other words, when an evangelical Christian asks themselves, "What would Jesus do?" this is a theory of mind cognition, trying to determine the intentions and moral concerns of Jesus Christ. And so their medial frontal cortex lights up, along with their superior temporal sulcus, temporal parietal junction, precuneus, and inferior frontal gyrus. Some studies in the neuroscience of religion use a technique called lesion network mapping. The idea behind this is that we can learn what different parts of the brain do by studying what happens to a person when those regions are damaged. You may have heard about Phineas Gage, a 19th century railroad worker who had a traumatic brain injury when an iron rod was driven through his head, destroying his left frontal lobe. Gage survived, somehow, but his personality changed completely to become much more violent, impulsive, and irreverent. This helped early neuroscientists understand the role that the temporal lobes play in our cognitive functions and personality. Though with lesion mapping today, modern neuroscientists have replaced the iron bar with a scalpel. Every day, people undergo brain surgery for medical purposes, like removing brain tumors. This inevitably means that parts of the brain get damaged, and if we gather enough data about people who go through brain surgery, then we might start to see patterns. That 2021 study I mentioned before about the periaqueductal gray was a lesion mapping study. The researchers analyzed patients whose temperament and character changed after their brain tumors were removed. 88 patients were asked about their religiosity before and after surgery. 30 of them showed a decrease in self-reported religious beliefs, 29 showed an increase, and 29 reported no change at all. On the surface, this is a fairly even distribution, so maybe brain surgery had no effect on the patient's religiosity. However, patients whose PAG regions were damaged were significantly more likely to self-identify as less religious. Now, 88 people is a small sample size, and there are inherent limitations to measuring religiosity with self-reported surveys, but the results do align with the idea that the neural pathways used in everyday activities are also used for religious cognition. In that PAG study, the same neural circuit that appears to support religiosity is also involved in pain modulation, fear conditioning, and altruistic behaviors. Other studies have found that certain religious practices seem to help some patients manage pain, and there are long-standing social theories that connect religion with terror management and the fear of death. Another lesion mapping study conducted by Jordan Grafman's team analyzed the nature of religious belief by working with veterans who had traumatic brain injuries. One study from 2017 found that damage to two specific regions of the prefrontal cortex were associated with higher rates of religious fundamentalism among these veterans. When they explored why this would be the case, the team concluded that this neural damage impaired cognitive flexibility and openness, which in turn predicted the increase in fundamentalism. Another study from the same group found that people with damage to the prefrontal cortex tended to report more religious experiences. This was likely due to impairment of executive functioning that would typically down-regulate these sorts of experiences. Interestingly, this increase in religious experiences also led people to see unrelated events as being causally connected, even without a plausible link between them. Now, to be clear, these studies don't show which parts of the brain cause religious belief. Instead, they show how specific neural networks shape the way people relate to those beliefs. Another interesting set of studies comes from the neuroscientist Patrick McNamara. McNamara's team works with participants who have Parkinson's disease, a degenerative disease caused by a buildup of proteins called Lewy bodies in the dopaminergic systems in the brain. These pathways are responsible for all sorts of processes, but are crucially involved in reward processing, the sense of worth or value that we attach to different things. In 2011, McNamara and his team found that participants with significant damage to these pathways had a harder time accessing religious ideas. The researchers studied 71 individuals with Parkinson's disease and compared them with 75 individuals without it. Both groups completed surveys about their religious attitudes and practices, and the study found that patients with the disease reported significantly lower levels of private religious practices, such as prayer or meditation, felt less divine forgiveness, and experienced fewer positive spiritual experiences compared to the control group. The researchers also explored the role that brain laterality plays in Parkinson's disease. Brain laterality refers to the asymmetric location of different functions within the respective hemispheres of the human brain. The disease can affect one side of the brain before the other, and the study found that patients with greater damage to the right side of the brain showed more significant declines in religiosity. They argue that this aligns with previous studies showing that the right front part of the brain plays a crucial role in religious cognition. To quote the study, the clinical data suggests that the limbic system, the basal ganglia, the right temporal, and the right frontal are key nodes that orchestrate religious cognition. Right frontotemporal areas likely mediate religious belief and ideation, and the limbic and basal ganglia sites presumably steer ritual behaviors and religious practices. Now, the study is a bit old at this point, published in 2011, and contemporary neuroscience now emphasizes that the brain is more of a dynamic network with interhemispheric cooperation between both sides of the brain, so we don't want to overemphasize the whole right brain, left brain thing. But location still matters for many functions in the brain, and studies on other clinical populations, such as those with temporal lobe epilepsy, schizophrenia, and frontotemporal dementia, have also shown that damage to these right hemisphere circuits can lead to altered religious experiences. A follow-up study built on this with cognitive psychology research on self-control. Some psychological research has shown a link between religiosity and the ability to delay gratification, holding off on short-term temptations for long-term rewards. Delaying gratification depends on the dopaminergic systems connecting the prefrontal cortex and the limbic system, which allows us to regulate desires and improve self-control. So the team compared older adults with Parkinson's disease and those without it to see if religious belief could still influence decision-making despite neurological damage. The researchers used something called religious priming. Now, this just involves reminding people of religious concepts like prayer or heaven to see if these reminders affect their behavior. They found that religious priming affected decision-making for the control group, but it had little effect on participants with Parkinson's. Moreover, brain scans revealed that specific regions involved with reward processing and decision-making were less active in individuals with the disease. They concluded that while religious belief might influence decision-making in adults without the disease, neurological impairments from Parkinson's can interfere with how these beliefs are accessed and applied. Now, after hearing all these case studies, it's crucial to recognize the limitations of neuroscientific research. A lot of these studies rely on functional magnetic resonance imaging, or fMRI. These studies measure oxygenated blood flow in the brain to create so-called hotspots that indicate activity, but the results are often averages that don't reflect individual variation. For example, if 3 people perform the same task in the fMRI machine, the final hotspot that makes it into the final report might represent the overlap of their brain activity, even if each person had very distinct patterns. Moreover, a 2020 meta-analysis found that even the same person's brain activity can vary when repeating the same task, meaning that fMRI studies often lack reliable consistency. Cultural factors can also affect results, as seen in a 2017 study suggesting that the link between mentalizing and belief in supernatural agents may be unique to the United States. Finally, beware of what's called the seductive allure of neuroscience. One study found that just referencing brain regions or showing data visualization of the brain can make flawed arguments seem more convincing. Now, this doesn't mean we should dismiss all neuroimaging studies, but we need to critically evaluate the quality of the research and compare it with other research from other fields. So when it comes to the neuroscience of religion, most of the research on religious cognition converges on a key takeaway: the same neural systems that we use every day for everyday tasks. The systems that shape how we store memories, delay gratification, process social situations, think about ourselves and what we care about, these same pathways shape religious cognitions as well. All of these different functions implicate different regions all across the brain. In some ways, this helps to demystify religion in the brain. While we might view religious beliefs and experiences as being somehow distinct from mundane beliefs and experiences, they all appear to follow similar pathways. Hey everyone, this was episode 1 in a new ongoing series on the scientific study of religion. I'll be releasing an episode every month or so exploring different topics on science and religion, like is religion an evolutionary adaptation? What do serotonin receptors in the brain have to do with religious experience? And are animals religious? This series was made possible through the support of a grant from the John Templeton Foundation, managed by the research organization, the Center for Mind and Culture. Another fascinating topic within the scientific study of religion is how quantum physics intersects religiosity. When quantum physics came onto the scene in the early 20th century, it upended many of our most basic assumptions about the nature of reality. The earliest proponents of the new physics, famous scientists like Einstein, Schrödinger, Heisenberg, and Bohr, found it to be counterintuitive and even downright strange. Some of the mysteries introduced by quantum physics include the discovery that matter can be both a particle and a wave, that observation can influence the state of matter, and that particles can influence each other across great distances, a phenomenon that Einstein referred to as spooky action at a distance. Quantum physics didn't just inspire scientific inquiry, though. It also sparked spiritual speculation. Many have drawn on quantum theories to explain parapsychological phenomena, like clairvoyance and telepathy, or to support concepts like spiritual healing and manifesting, often referred to as quantum mysticism or quantum spirituality. If quantum mysticism sounds interesting to you, we'll be offering an online lecture on the topic taught by Princeton University's Dr. Rachel Carbonara. We'll be holding the lecture online over Zoom on Wednesday, January 29th at 12:30 p.m. Eastern. Dr. Carbonara will walk us through how theoretical physicists like Bohr linked scientific and spiritual inquiry in their work, and how many people have engaged in speculative thinking, explaining religious and spiritual ideas with quantum physics. We're in for a treat for Dr. Carbonara to be teaching this lecture. She's a postdoctoral research associate at Princeton University, and her work examines New Age spirituality, with a focus on practices like manifestation and energy healing, which are topics we've explored here on the channel before. If you'd like to join the lecture, you can register at religionforbreakfast.eventbrite.com. Registration costs whatever you want. I don't want cost to get in the way. And again, that will be held on Wednesday, January 29th at 12:30 U.S. East Coast time. It's a 1-hour lecture followed by 30 minutes of Q&A that I'll be moderating. These are always a lot of fun. They're great opportunities to dig deeper into the topics we cover here on the channel. Again, that's religionforbreakfast.eventbrite.com, and I hope to see you there.